Next up is the thyroid and parathyroid glands. The thyroid gland is a butterfly-shaped gland. It is located just anterior to your larynx, which is your voice box, which is right here going around your trachea. You could also, your other major landmark is going to be your Adam's apple, which you're going to learn is called your thyroid cartilage. It's that big V cartilage in the front of your throat there. So just inferior to that is going to be this thyroid gland. It's got two big lobes on it that look like a butterfly, and then sometimes in the middle there will be a pyramidal lobe of the thyroid gland. So here's a thyroid gland sitting on a cadaver. You can see the two big lobes here, and then in the middle, separating them, is the isthmus. And here you can see it right here. Here's the isthmus. If you've seen pictures of some islands have a little isthmus, that's the little narrow section between the two. And you'll notice that there's not a pyramidal lobe here in this one. We don't always have pyramidal lobes. This thyroid gland is made up of a lot of little follicular cells. Those follicular cells are over here. You can see are making a little circle here. That circle is going to be surrounding what's called the thyroid follicle, and it makes up this follicle, and it's in this follicle that its two major hormones are going to be produced. We've got triiodothyronine, or T3, and then we've got thyroxine, which is also called tetraiodothyronine, T4. T4 is the inactive form, so thyroxine is actually inactive, but our body makes a lot more of it than it does the T3. But that's okay, because that's just how it's going to travel until it gets to its target cells. And then it goes into the target cells, and the T4 gets converted into T3, and everything becomes active and it's on its way. Now, the reason why they've got this big, long, old name to them, triiodothyronine, means that there are 3 iodine molecules that make this up. And tetra means 4, so that's why it's called tetraiodothyronine, and that's why these are called T3 and T4. They require iodine to be made into their hormones. What they do is that they're going to regulate a few things. They're going to regulate our oxygen use and basically our basic metabolic rate, and that metabolic rate is basically going to be the combination of all the chemical reactions going on in our body. So they're managing our energy usage, which kind of leads us into cellular metabolism, how that's being used, and that all leads into growth and development. So the thyroid hormone is really essential for managing our energy levels. And you may hear of people, especially as we get older, our bodies tend to not produce as much thyroid, and people end up taking thyroid medication to basically supplant this thyroxine. So you may hear medication Synthroid, which is basically a synthetic thyroxine that people can take to keep their energy levels up. What this is a big goiter, and a goiter is basically an enlarged thyroid. And people can get these enlarged thyroids for 3 main reasons. One is that they don't have enough iodine in their diet. If they don't have enough iodine in their diet, then they're not going to be producing as much T3 or T4. If they aren't producing as much T3 and T4, the hypothalamus and the anterior pituitary are going to say, hey, what's going on here? There's not enough thyroxine in our system. We need to make more. So they keep putting out thyroid stimulating hormone to stimulate that high thyroid to make more and more and more. Let me just draw you something. I'll put something a little in here to show you kind of how this works. So imagine here now that you've got your hypothalamus, and your hypothalamus up here is going to be secreting thyrotropin releasing hormone. So that's coming out of this region up here, thyrotropin releasing hormone. That's going to be positive, and that's going to be signaling the anterior pituitary gland. This is the one that you really got to know. Is going to be the thyroid stimulating hormone, which is going to affect the thyroid gland, and that's going to make our T3 and T4. So normally this T3 and T4 will be going out to the body, but remember, there's going to be a negative feedback loop going up to the hypothalamus and over to the anterior pituitary. So when we get too much T3 and T4, it's going to tell these guys to slow down the production of the releasing hormones, the thyrotropin releasing hormones and the thyroid stimulating hormones, so that you make less T3 and T4. But if you're not getting enough T3 and T4, you're not going to slow down this system. So you lose that negative feedback loop. So the body, the hypothalamus and the thyroid stimulating hormone keep telling the thyroid to make more and more and more. And that's why we get this big old goiter. So the easiest thing that we can do is to add more iodine into the diet, and then they can start producing the T3 and T4, and that will get that negative feedback loop going in, and then the thyroid gland will reduce. Another way that you can get this is that you can have overproduction of hormones due to a tumor. So again, if you have like a tumor in the anterior pituitary gland or in the hypothalamus, that's when a tumor is active, it's dividing and making more and more and more cells, and those cells are going to produce more and more hormone. So that's going to end up making more T3 and T4. And as the thyroid stimulating hormone is increased, that's going to be telling that thyroid to grow. The last way is kind of interesting. It's our autoimmune system gets involved. And what happens is some of those autoimmune cells actually go to the receptors for what would be thyroid stimulating hormone on the thyroid gland, and they continue to stimulate those receptors independent of how much thyroid stimulating hormone is there, and they just make this thing turn into a big factory of making more T3 and T4. So a couple different ways that you can actually get these goiters, and they're all surrounding this thyroid gland. So we were just looking at these follicular cells that make up the follicle. Now there's other cells in the thyroid gland called the parafollicular cells, or C cells, and they're right next to the follicle cells or follicular cells. So they're kind of in between all these follicles. And these parafollicular C cells produce calcitonin. That's why they're called C cells. And they're going to regulate the calcium in the blood, and they do this by a negative feedback loop, like most of these things are regulated. So when there's a lot of calcium or too much calcium in the blood, calcitonin is going to be secreted, and that's going to do one of three things. In the bones, it's going to cause increased osteoblastic activity. So if you remember the osteoblasts from way back in chapter 6, those osteoblasts are going to pull calcium out of the blood and put it into the bones, and they're going to be the bone builders, right? At the same time, it's going to decrease osteoclastic activity. So we're not going to be, those osteoclasts were breaking down the bone and putting calcium into the blood. So we're limiting those and we're increasing the osteoblasts. At the same time, it's going to have an effect on the kidneys. Now, the way the kidneys operate, and we're going to learn this more on a whole couple chapters, or on the whole chapter on the kidneys, is they filter your blood and they kind of take out the plasma and the stuff in the plasma, and they decide how much of that is going to stay and how much of that is going to go. Well, if you've got too much calcium in your blood, it's going to allow that calcium to be excreted in your urine. So it's another way of pulling calcium out of the blood. The third way is that in your gastrointestinal system, so your small intestine especially, it's going to reduce the amount of calcium that gets absorbed from your gut into your blood. So we're limiting how much calcium comes into your system. And then we're pulling the calcium that we have in your system out of the system by putting it into your bones or out your kidneys or out into your urine. So that's three ways that calcitonin can manage that calcium level in your blood. So it's going to result in decreased calcium levels, and it's going to result in decreased incidence of osteoporosis because we're building up your bones with calcium. So calcitonin can be a good thing for that condition. Now on the opposite side, so that thyroid gland, we're looking at this now from the posterior surface now. So you can see this is the back of the person's head, and that on the back side of that thyroid gland, there's these 4 little green nubs here that you might see. Those little guys are called parathyroid glands. They're just teeny. There could be 4, there could be 3 or 5 of them, but generally we say that there's 4 of them. And the way they work is this. They are going to secrete a hormone called parathyroid hormone because they're the parathyroid gland. It's also called parathormone, and it's going to be, so if these are your little parathyroid glands, here's the whole thyroid, here's the pyramidal lobe, the 2 lateral lobes, and here's our little 4 parathyroid glands. This parathormone or parathyroid hormone is released from chief cells. So the way this kind of looks schematically, here is your follicular cells with your follicle. This is where all the T3 and T4 is made. Well, in the parathyroid part of this gland, in the parathyroid gland, you're going to have a bunch of these little chief cells, and these guys are going to be making the parathyroid hormone. There's also these other cells in here called oxyphil cells, and what I know about them is that when people have metastatic cancer, they can also produce parathyroid hormone. So these chief cells are what's making the parathyroid hormone. You can see them here in a little electric microscope blow up all these little chief cells surrounded by their oxyphil cells. And the whole point of these guys is that they're going to be antagonistic to calcitonin. So we know calcitonin was made when there's too much calcium in the blood and it's storing it away. Well, what parathyroid hormone does is it pulls calcium into the blood. So if the blood calcium is low, it's going to signal for it to make more calcium in the blood, and it also is going to pull in magnesium, and it's going to reduce some of the phosphates that are in the blood as well. So it does that by the exact 3 opposite mechanisms that we saw with calcitonin. So if you have low blood calcium, then in the bones, it's going to increase your osteoclastic activity. So it's going to be pulling calcium out of the bones. It's going to, in the kidneys, instead of excreting calcium into the urine, it's going to take that filtrate and it's going to pull more calcium out of the filtrate and put it back into the blood. So we're pulling calcium in that way. And then the third way is that it's going to increase the formation of calcitrol. And calcitrol is basically vitamin D. It's a precursor of vitamin D. And what it's going to do is in the kidneys, it's going to increase, or vitamin D is made in the kidneys, and it's going to increase the calcium that's absorbed in your gut. So how much calcium you're actually taking in when you eat calcium. So it's going to be helping all of that. So those are 3 ways we can bring the calcium back. So these osteoclasts aren't always bad boys. I mean, if we need calcium, and we do need calcium because calcium is an integral part for nerve conduction and for heart rate and for muscle contraction. So if the calcium is low in our blood system, we're not going to be operating very effectively. So we got to take it out of our storage units, and those are going to be in the bones. And that's how we're going to get it. And we're also going to absorb more from our nutrition, and we're not going to pee out as much. So we increase the blood calcium and we increase the absorption in our gut. And that pretty much wraps up how our parathyroid gland works to control or be antagonistic to our thyroid gland.